A short video about how to find out which things are fast in Haskell. I had a question where one person in my course was looking at a program like this. Simple count function, very obvious to do. And thought, could I make it faster by having more base cases? So if I had a base case for single element list, would that make the thing very much faster? Or if I would have base case for 7 element list, would that make things faster? Of course, this is very much similar to concept of loop unrolling in other languages like C and Java. And the idea is that instead of consuming one element at a time and then making a recursive step, you could consume 7 elements at a time and then make a recursive step. And this is actually a rather good idea. At least in imperative languages it works. And it turns out that for this function it works also in Haskell. But the big question is that how do you find out about these things? It could be that the pattern matching is more expensive than a function call, and this wouldn't work. The problem, however, with Haskell is that it's very hard to naively benchmark your functions. So if you have a function that reaches your timer and function that you want to benchmark, then you could think that you can compose a timing function by reading the global clock, then calling your function and reading the global clock again and measuring the difference. The problem is that Haskell is lazy. So in most cases this wouldn't work. You would call your function, then the lazy Haskell would not evaluate your function at all because nothing is consuming the value, or it would evaluate it to some weak normal form where it basically has the first constructor of your list or something similar. So people have been stumbling upon this topic for a long time and come up with a library called Criterion. Criterion makes it automatic to benchmark Haskell functions. It takes care of having your functions forced to a normal form and takes care of calibrating your clock and running repeated experiments. So, how does Criterion work? We first import criterion.main, which gives us this nice function called default main. Default main is similar to game in window function, which we had in the asteroids game, in a sense that it produces a main function. Well, in Criterion the default main takes a list of benchmark cases, and the benchmark cases are constructed with function bench. Bench takes a name and then the benchmarkable function. And here is the tricky part. For the benchmarkable function you need a forcing function like WHNF or weak head normal form, which tells you how much of the result you need to evaluate. And this function takes your pure testable function and its parameters as a parameter. And this controls mostly how you evaluate the things, so you don't have to worry about if the list is half evaluated or not. In this case we could use the weak head normal form, or if we that returns a complex structure we would use something like NF, which means normal form. But for thing that basically returns count or integer, it's very easy to do. So what we do, we make benchmarks of all 3 cases and give some parameters. We take a list of numbers from 1 to 10,000 to just make an example. And then we build the program. And since this is running in a virtual machine, this is a bit more slow than it usually would be, but let us do like this. And simply running this program with the new default main generates all the code that we need for measuring our clock resolution, measuring how much other processes are running in the system affect our results. And it spits out quite nicely results of our program. And in this case we can see that yes, count3, which consumes 7 elements at a time, is plenty faster than the other variants. Then we could try this same thing with optimization enabled. So something like this. Usually optimizations in Haskell are very important and have extremely large effects on the code performance, probably even more so than in C. And we can see the effect of optimizations here. Previously we had count2 taking almost 500 microseconds. Now we have 60 microseconds. And the speed difference between count3 and count2 is about 50% or a bit less, 48 or something like this. So yes, actually we can deduce from this that pattern matching is cheaper than function calls, and at least when you are reducing your number of function calls by a factor of 7, it's very beneficial to do. So this is how you can benchmark your Haskell programs easily.